Hello. Hello, everyone. Welcome to our webinar. My name is Laura Perez from Marketing KUKA team, and I am thrilled to be your host today. We have an exciting session lined up for you. But before we start, let's go over a few housekeeping items. First, this webinar is being recorded and we will share the recording with you afterwards. If you have any questions during the presentation, please type them into the Q&A box and we will address them during the Q&A session at the end. So now it is my pleasure to introduce our speaker for today, Saransh Gupta. Saransh is a KUKA applications engineer with a decade of experience in robotics and warehouse automation. Currently serving as exclusive application engineer for industrial robots and solutions at KUKA Canada. Successfully completed numerous projects involving KUKA.CNC and milling applications, consistently delivering tailored solutions to meet client needs. And we are honored to have him with us today. Welcome, Saransh.
Thank you, Laura. Thank you for the introduction. Hello, everyone, and welcome to today's webinar. Before we begin, I just want to mention that I'm dealing with a bit of a cold, so if my voice sounds off or I need to pause for a moment, I really appreciate your patience. That said, I'm excited to walk you through today's topic, and let's get started. So in this webinar, we will explore the KUKA.CNC system and the milling package, highlighting its capabilities, features, and applications. The session will cover key aspects of robotic CNC machining and provide insights into how KUKA robots can be effectively utilized for milling applications and tasks. The following are the contents which we'll be going through during the entire webinar. We'll understand what exactly KUKA.CNC is, some of the user benefits and USPs, some standard KUKA.CNC functions, CNC interface with smart HMI features and functions, robot programming and its integration, the modular use of KUKA.CNC, the robots which can be used for machining application, an overview of a milling system, the components of the milling cabinet, an extension with KUKA external access, and some additional options. Some important terms before we begin, which will come throughout the webinar session. EMI. EMI is your external motion interface. This is an interface which enables the robot to be moved on the basis of a NC program. MDI is your manual data input. This is an operating mode for setting up of the CNC machine. Short NC blocks can be specified in your MDI block. PLC, as most of you must be knowing it, is a programmable logic controller. It's a module for higher level control tasks in a bus system. Then what is KUKA.CNC? KUKA.CNC is an advanced add-on technology package designed to enable seamless execution of NC programs directly on your KUKA robots. It provides full CNC functionality, allowing users to control and program robots similarly to the traditional CNC machines which are there in the market. Key functions of KUKA.CNCs. First, it runs all the CNC programs which are generated from CAD or CAM systems, as well as your manual data input blocks. It displays real-time runtime data for monitoring and optimization. It also allows on-the-fly adjustments and modifications to enhance the flexibility. Most importantly, the CNC kernel runs alongside the KUKA kernel, ensuring smooth integration and execution of the process. Some advantages: it has a CNC-like interface, which provides an intuitive and familiar experience for CNC machine operators. It has advanced path planning with a look ahead for over 200 points, which in general cases, it's around 5 points of look ahead. Full G-code compatibility, which enables direct execution of standard G-code programs without conversion. Application-specific M commands can also be customized for different machining and automation processes. Seamless switching between KRL and CNC, with which users can switch between KUKA robot language and CNC mode easily. Nearly unlimited or with no restrictions on the program size, allowing for complex machining tasks. So the user benefits. With KUKA.CNC, KUKA is the only manufacturer offering a CNC kernel within its control system to control the robot motion with G-code commands together with all other robot control functions. This is available for KSS 8.6, where we have KUKA.CNC 3.0 version, and KSS 8.7, for which we have CNC 3.1 version. This software enhances material removal and additive manufacturing processes. It offers best-in-class path performance as it has a look-ahead path planning of 200 points. It has path optimization parameters, which provide flexibility for different applications. Also, advanced interpolation guarantees continuous and precise movement. And CNC functions and features for the robot. Direct G-code programming is available for robot machining. Seamless CAD and CAM integration for offline programming. Essential G-code functions like tool radius compensation and zero offset can be done here. It supports large programs even with over 1 million points for complex machining. It has accuracy improvements option where backlash compensation for A1 can be enhanced for motion accuracy. It has optimized motion parameters, which improves precision and consistency. Tool compensation enables real-time adjustment for better machining results. Therefore, KUKA.CNC continues to be a leading solution for robotic CNC machining, offering increased efficiency, accuracy, and compatibility with advanced manufacturing technologies. Here, we are discussing about the KRC4 integration of a robot controller with CNC. This diagram highlights the modular and structured approach to implementing KUKA.CNC with the KUKA robot controller. The first step here, what you're seeing is the NC program input. The system starts with the NC program, which is also called as numerical control program, which contains the machine instructions for performing CNC tasks such as milling or machining. The NC program is interpreted by the KUKA.CNC module itself. On the second step, which is KUKA.CNC module and a KSS integration, the KUKA.CNC module acts as the primary interface for executing the CNC program. It processes G-code instructions and interacts with other system components. Communication between KUKA.CNC and KSS occurs through the EMI, which is again external machine interface, ensuring synchronization with the robot controller and other control processes. Simultaneously, KUKA.CNC also communicates with the Proconos, which is a soft PLC, and the CNC kernel for advanced motion planning and real-time coordination. Proconos and CNC kernel is the step 3 integration, where it manages logic operation and peripheral control, while the CNC kernel focuses on the real-time processing of motion commands, which are derived from the NC program itself. This ensures precise execution of complex trajectories and coordination with the robot. Then we have the step 4, which is periphery and robot integration. The KSS transmits control signal to both the periphery and the robot via this EMI interface. This integration enables synchronized operation between robotic movements and CNC processes, allowing seamless execution of tasks such as milling, cutting, deburring, engraving, etc. The 3 independent systems. The integration of Proconos KUKA robot controller, and the customer PLC. This is an overview of how the internal Proconos with soft PLC, KRC, and an external customer PLC collaborate via field bus communication, can achieve seamless data exchange and control in any industrial application. Proconos, the internal PLC, is embedded in the KUKA controller for handling logic and process automation. It communicates directly with the KRC. For example, uh, outputs from Proconos can be configured as KRC inputs, enabling synchronized operation between the robot and PLC logic. Then comes the KRC, KUKA Robot Controller. The KRC oversees robot motion control and integrates additional functionalities such as CNC processes or custom user applications. KRC can send data back to Proconos, therefore facilitating a two-way communication for controlling complex tasks. Then comes the field bus interface. A field bus acts as the communication bridge between the internal KUKA components and external customer PLC. Output from Proconos or KRC are transmitted to the field bus and subsequently relayed to the customer PLC as inputs. Similarly, the inputs from the customer PLC are passed through the field bus and received by Proconos or KRC, allowing for dynamic interaction with external systems. Then is the customer PLC. The external PLC is responsible for overseeing and executing additional automation processes within the production environment. It communicates bidirectionally with the internal KUKA system via the field bus, enabling integration with broader industrial setups. Then some standard KUKA functions. These are some standard KUKA functions which are available in the KUKA.CNC technology package. There are standard G commands like G00, which can be used for rapid positioning of the robot. We also term it as PTP motion. G01 is for linear interpolation. G02 and G03 are for circular interpolation. G04 can be added for adding any wait time. G40 for deleting any tool offset, G90 for absolute positioning, G91 for relative positioning of the robot, and so on. There are certain standard M commands available, like M00, which stops the program, M02, which ends the program, M03 is for switching on the spindle, 05 for switching off the spindle, and so on. M100 and 101, 102, and so on are also available. These are for flexible use of customer specific M functions for a flexible integration of different process commands. Some additional commands like a percentage symbol can be used for starting the program. N denotes for the line number, S is for the speed of the spindle, F is for machining velocity, and T is for the tool number. This is what the CNC user interface looks like on the Smartpad of our KUKA robot controller. Here on the left side, you'll see the KUKA.CNC basic screen, and on the right side is the automatic operation in progress. Robot mode and CNC mode can be switched directly. Complete operation via Smartpad is possible. We'll discuss about some of the smart HMI features and its functions. To start with, we'll go to deep integration into the KUKA world together with a larger CNC Explorer. So one gets a very nice CNC Explorer on the Smartpad itself. One HMI integrated into the whole robot menu to get direct and quick access to CNC menu functions. There are status keys available to access the CNC menu. You have two ways of accessing the menu. First one, you can directly select the interface you want through the robot menu. And the second one is to use the status keys to navigate through the CNC interface. You can toggle through with a short press or press and hold for selections. Hardware buttons customized for KUKA.CNC are to save time and ease of use in operation. There are more viewing areas available for a better and more specific overview and some CNC information, like information about the program. If you want to see the program, if you want to edit the program file, it becomes much more easier. One can double the size of viewing space for editing the files. There are certain ISG documentation available on the HMI itself. Quick access to specific CNC information. You have the search function for operator-friendly use. One can directly access these documents on the Smartpad. There is block selection tool available for easy restart of with at an interrupt, or start or restart at a specific block point, or start and restart at a specific block count. Better and improved diagnostics. These are also available on the Smart HMI itself. So you can generate the diag data, which is visible and it's more intuitive. You also get the trace functionality. Embedded trace functions within the KUKA standards can be used in the diagnostic view itself. One gets extended M functions. M functions for customer specific commands can also be configured within the KUKA.CNC system. Then comes the installation of KUKA.CNC. The option package is installed using Work Visual and further added to the project. When the project is transferred to the robot controller, the option package is automatically installed there. You can install the option package in the Work Visual first. Depending on your choice, whether you want a simple version of CNC or the advanced version of CNC, you need to install and you need to export and install the development file from the catalog itself. Further, one can load the active project from the robot controller as well. You can insert the option package into the project depending on the choice, simple or advanced. You can install Proconos first and insert the CNC multiproc template, or just drag and drop the Proconos CNC option to the project. Deploy the work visual project on the robot controller and activate it, and it's as simple as that. CNC can be simple version or an advanced version. Simple CNC, you don't need a multiproc. You just can use the fixed IOs variables. No additional functions of CNC will be available in it. Whereas in the advanced CNC, which is by multiproc, you need to buy a multiproc and Proconos. You have to execute the development file and you can add functions and variables. With KUKA CNC, the work visual integration is also seamless. One can do the configuration using the work visual. It's easier and faster to set up the system. Advanced system configuration and functions are available. Work visual online editing is an option where one can directly change the programs and deploy into the controller. Syntax highlighting for NC commands is also available there. Then comes the CAD/CAM process chain, some of the CNC programming for robots. Offline programming for CNC operations involves generating machine-specific G codes using CAM software, which is computer-aided manufacturing. CAM systems are software platforms which are designed to convert CAD models into G codes that can be interpreted by the CNC machines. They offer a user-friendly interface to simulate machining processes, test different tool paths, and also optimize cutting strategies without interrupting the production. The second part of it is the post-processor for G code generation. Post-processor is a vital component for CAM systems that translates generic toolpath into machine-specific G codes. Ensures compatibility with KUKA CNC as well. It can also be tailored to specific machine kinematics, tool orientation, and controller configurations. Some of the advantages of CAMS-based CNC offline programming is one gets better efficiency, better precision, gets the flexibility, which supports both simple and complex machining operations, and optimization. All CAM systems provide post-processor to generate machine-specific G codes. It can be a 3-axis machining process, which has tool orientation as constant. So it's fixed perpendicular to the workpiece. It is suitable for planar surfaces and parts which require simple contouring or drilling. Some examples like flat components with molds or plates. Then comes your 5-axis machining process. In this, the tool orientation is flexible, allowing the tool to approach to the workpiece from any angle. Application, it's ideal for complex geometries and undercuts where multiple planes must be machined. Examples could be your automobile industry or aerospace industry and so on. Then you can see here example of a KUKA.CNC general program uh, where it starts with G1, which is a linear interpolation. Then you see X, Y, Z, and then the orientation with F as a feed rate, which is 30,000 here as mentioned, and so on. You have X, Y, Z values, orientation, and then the feed rates. You can change the feed rates wherever required. Then these are the content of a NC line. It has certain N, G, X, Y, A, F, S, and M denotions. N is for block number, G denotes the movement function, X is for position, Y for position, A is for angle, F feed rate, spindle speed, and M for machine functions. Path performance. The path performance in KUKA.CNC refers to the robot's ability to follow a specified trajectory with high precision and at a desired speed. Some of the key factors are like interpolation. CNC uses a spline-based interpolation mechanism to ensure smooth and precise movement along the program path. High performance interpolation minimizes the deviation and also ensures accuracy at higher speeds. Then is the path smoothness, which is essential for avoiding any vibrations or abrupt movements, which can further degrade the quality of the machining process. Certain factors which influence the path smoothness are trajectory planning. As already discussed, KUKA.CNC has a look ahead of 200 points, so it has a better path planning and also better interpretation with smoothing filters. KUKA.CNC has significantly improved velocity control compared to any traditional robot control approaches. This enhancement is crucial for machining, milling, and other high precision applications where maintaining consistent velocity along the path directly impacts the surface finish and also the tool life. There are certain reasons for improved velocity control. Advanced interpolation technique, you have a look ahead functionality, adaptive feed rate control, which can be adjusted in real-time basis on path complexity. This ensures the robot maintains optimal velocity while adhering to path constraints and avoiding any overshooting. Then you can further optimize the G codes for better accuracy. The modular use of KUKA.CNC. It has the ability to run both KRL robot programs and CNC programs. KRL batch mode for CNC execution. The NC program will be handled like a subroutine. So once one NC program finishes, the robot can continue with the robot program. CNC mode, the use of a CNC HMI, directly run the CNC program, and then you can also edit and process the CNC programs within itself. Then comes the machining part, or material removal applications. There are certain robots which are suitable for machining applications. We have 3 series, IronTech, Quantech, and Photech. In the IronTech series, we can use KR10, KR22, KR70, 50, 30. These are the low payload category robots which can be used for machining application. Then we have a mid-range where KR50 or KR300, the Quantech 2 series can be used, and KR360, KR500, and KR500 MT version are the Photech versions which can be used for heavy machining applications. In my experience, I have seen IronTech and Photech to be performing better. They have a little better accuracy. They have an edge on it over the Quantech one. The applications which this can be used is foam material, different type of plastics, wood components, aluminum components, carbon reinforced plastic, stone, aluminum, heavy wood, and metal machining can be done with these robots. There are certain tests which are conducted internally, and cert possible applications for a KR70, the IronTech robot series, are your 3D model making, deburring, trimming, grinding, polishing, cutting, chamfering, 3D printing, and so on. These are suitable for materials like clay, wood, aluminum, plastic, bronze, and so on. The part size is 750 by 750 by 750 millimeters on which these tests were conducted. The single part accuracy observed with a IronTech robot was 0.4 millimeters, whereas the serial part, which is the repeat accuracy, was 0.2 millimeters. The maximum process forces for this is 500 newtons, and the spindle which is used for this particular robot size is a 8 kilowatt spindle. So we have three different type of spindles available: 8 kilowatt, 12 kilowatt, and 16 kilowatt spindles. Then the Quantec 2 package for KR150 and 120. Here we offer 8 kilowatt and 12 kilowatt spindle package. The applications: 3D model making, deburring, trimming, similar to the IronTech series. The materials here: clay, wood, aluminum, steel, cast iron, and so on. They can be used here. The part size is 1000 by 1000 by 1000. The single part accuracy observed here was 0.5, whereas the serial part was 0.3. The maximum process forces it's suitable for is 750 newtons. Then comes the Quantec 2 package for KR300 and 250 robot. It's suitable for applications like drilling, deburring, trimming, cutting, chamfering, etc. You can use plastic materials, glass fibers, aluminiums, cast materials, and so on for this. The part size considered here is 1000 by 1000 by 1000, with which we got a single part accuracy of around zero point 0.6 to zero point 0.7 millimeters and a serial part accuracy of 0.3 millimeters. The maximum process forces was 1000 newtons. Available with all the three: 8 kilowatt, 12 kilowatt, and 16 kilowatt package. Then comes the Fortec package, where it's used for drilling, deburring, trimming, grinding, and cutting applications, suitable for aluminum, carbon, steel cast material, and so on. The single part accuracy was 0.8 to 1 millimeters, whereas the serial part accuracy was 0.4 millimeters. The maximum process forces were ranging between 1500 to 8000 newtons and is available with 12 kilowatt and 16 kilowatt spindle. We also have small robot packages, which is edgeless robot. It's suitable for very light machining application. It's for 3D model making or deburring or trimming, and for materials like plastic and wood. The single part accuracy was 0.4 millimeters and the serial part was 0.1 to 0.3 millimeters. Maximum process forces for this is 100 newtons. Then comes our milling system. I'll talk about the overview of a billing system a bit. Here, the first one, what you see on the screen is the manipulator. It can be IronTech or Fortec or Quantec. We have the energy supply system with the K box. The third one is the electrically driven spindle. The fourth one is the controller. The fifth one is your Smartpad. The sixth one is the technology cabinet with integrated safe PLC and pneumatic systems. The seventh one is the tool cover, and the eighth one is the tool rack with 10 tools. It comes as an optional package where one can choose between a tool rack with the cover or without the cover. The first milling component, which is the robot system, it has manipulator. The recommended robot types, as we discussed, depends on the spindle power and process forces. KR IronTech, Quantec, or Fortec series can be used for heavy forces. Robots should be equipped with positionally accurate calibration option for increased absolute accuracy. Application-specific energy supply systems from axis 1 to axis 3 and axis 3 to axis 6 are including with the K-box. You get motor and control cables for relevant machining spindle. You get pneumatic clamping system, pneumatic hoses, water supplies, and its return lines, and so on. Adapter plate for spindle fastening is also available there. Then comes the KRC4 with KSS 8.6, the controller. It should be installed with ProfiSafe X67 safety interface. It should have 27 volts power supply. It has KRC4 software packages like KUKA Profinet, Proconos, HMI Xenon, which is for the ready-made HMI, and KUKA User Tech. The preferred option currently for CNC is KUKA.CNC 3.1. Then comes the milling cabinet itself. The milling cabinet has different components like connection panel itself. You get frequency converter, temperature controller, air filters, 24-volt power supply, pneumatic system. It has safe relays, safe PLC, and transformer for recooling system, etc. These are the these are the spindles which are supplied by KUKA. We have three different type of spindles available: 8 kilowatt, 12 kilowatt, and 16 kilowatt. The 16 kilowatt spindle is also available with UL certification. Preferred robot type for 8 kilowatt is INTech series or the Quantec 2 robots with 120 to 150 kilogram payload capacity. Whereas for 12 kilowatts, it's Quantec 2 or Fortec, and similarly for 16 kilowatts. The maximum speed for 8 kilowatt is 36,000 RPM. For 12 kilowatts, it's 24,000 RPM, and for 16 kilowatts, it's 22,000 RPM. These spindles are suitable for plastic, wood, fiber reinforced materials, aluminium, steel, etc. The tool clamping system is different for 8 kilowatt, it's HSK E40, whereas for 12 and 16 kilowatt, it is HSK F63. All the three spindle types come with IP54 rating. Here is the spindle, is the image of the spindle, where the main components are like air connections. You get the cooling water return connection, the supply connection, signal connections, motor cable connections, and also a manual tool release push button. This is an optional tool changer rack. This rack, as I mentioned earlier, these are available in two different options. One is without the cover, the other one is with the cover. It's available for both HSK E40 and HSK F63 tool holders. There are 10 tool changing positions, and the dimensions per station for 8 kilowatt is 80 millimeters diameter, and for 12 and 16 it's 105 millimeter diameter. Monitoring of each tool position is possible as the system is integrated with sensors and bus module. 10-meter connecting cable for technology cabinet. Then we also have a gate lock, which is an optional item. A special gate lock is required for all the milling applications. By default, the safety programming on the safe PLC in the technology cabinet is rated. It's pre-programmed and parameterized for up to 2 Ushner gate locks with active locking. Gate locks from any other manufacturer can also be integrated into the safe PLC and must be extensively tested. The gate locks can be of two types, can be a right-handed side or a left-handed side. Then comes the milling robot HMI. A milling robot HMI is different from the KUKA.CNC HMI. If you access the milling robot HMI, this is what you see. This is the start screen where you get buttons for switching on and off the chiller, main air, and also tool cleaning here. You can set the spindle override as a percentage of the spindle speed. Buttons for switching on and off the spindles are available. Buttons for clamping and releasing the tool is also available. You can also access the milling system error messages. A button is also available for acknowledging all the error messages. One can display the spindle speed, also enter the spindle speed, and also set the direction of the spindle rotation. Then if you click to the second tab, on the second tab, you see the spindle view. There is a button for displaying the frequency converter inputs and outputs, which is used for troubleshooting. You get the status indicators. The status indicators for the tool rack is also available. Status indicators for spindle is also available. Then on the third tab, you get the periphery view. Buttons for switching the main air and tool cleaning is present there. You get the fault indication, button for switching on and off the chiller, error indication if there's any, the flow rate or temperature errors, chiller status indication, and main air status indication is available on the HMI itself. The third tab is for the fourth tab is for tool changer itself. You get the buttons for opening and closing the lid of the tool rack. You get the LEDs for displaying the 10 tools. Whichever tool is present, that will be indicated there. Tool rack status indication is also available here. The last one is the expert view. You have 3 buttons over there. The quit all is the button to acknowledge any error messages on the milling system. Lamp test is to test the indicator lamp on the milling controller, and then KUKA config, which will display the configuration. Further, one can extend the workspace of the milling application by adding external access to it. There are linear axis or rotary axis which can be added. Linear axis is the operation with linear axis for maximum extension of the workspace, particularly for long, large volume parts. One can use turntables and turn tilt tables. This operation with KUKA turntable and turn tilt positioners for optimal positioning of workpiece in machining processes. Some additional options and modular cell solutions with system integrators. We have some suppliers for tools for the end mills, and some certain flexible clamping solutions are also available from Daimler and Schunk. There are certain offline cam systems which are available for the robot. We have Robot Master, we have Power Mill, Octopus, Tebes. These are all the tried and tested versions. They are the ones who have the capability of generating a NC code for a KUKA robot. Some external hardware options, depending on the application, you can choose the grinding or polishing tools. You can also access force torque sensors from ATI or Schunk. Then the last one is the calibration devices. These calibration devices can be used for calibrating your tool during the process. Leone is the calibration system for optimized automated TCB calibration, whereas Renishaw and Blum Novotest are for tool length and tool wear calibration and controls. Yeah, with this we come to an end. Now we can have certain questions if there are any. Any questions?
Not yet. Customized for different applications. And what is the cost?
Yes, as mentioned, it can be customized for different applications, whether you're looking it for machining application, 3D printing, 3D model making, and so on. The cost is something which I'm not the right person for it. You can reach out to our KUKA Focus Center. They can direct you to the concerned sales department and the person there.
Okay. I don't see another question. Siemens 840D. I don't know, Alexandra.
Sorry, what's the question?
I only see the Siemens 840D, but I don't see. Here I have one. What is the speed and feed? Okay, what is the speed and feed when cutting part on cast iron and steel? Can you send a spindle torque curve?
Yeah, you can anytime reach out. As I mentioned, you can, for more details, you can either access our expert.com. There you can get the data sheet for the spindles. If not, you can reach out to our focus center team. They are available 24/7, and they can direct you to the concerned or the right technical or the sales colleague for it. And the speed for the part of on cast iron or steel, it basically depends. It depends on the type of material, the hardness of it, and the process what is required. Any other question, Laura?
No, I don't. I don't have another one. Thank you for that insightful presentation, Saransh, and
Yeah,
for
thank you again.
answering
Yeah,
your questions and for the presentation. Thank you for all our attendees for your participation and engagement, and we hope you found this webinar valuable and informative. Goodbye and take care.
Industrial intelligence.